All right, problem number 38 says to rewrite sine 2x cosine 3x as a sum using the formula sum sine u cosine v is equal to 1/2 sine u plus v plus sine u minus v. So the formula that you're supposed to use is given. So if we line this up over here, you can see we're putting 2x in for u and 3x in for v. So come over here to the formula, put 2x in for u, 3x in for v, 2x in for u, 3x in for v. So then that gives us 2x plus 3x is 5x and 2x minus 3x is negative x. And basically that is our product to sum formula. All right, then for 39 it says find the tangent of x over 2 if cosine equals 4/5 and x is in the fourth quadrant. Okay, so if I want to find tangent x over 2, look on your formula sheet and you'll see that's sine x over 1 plus cosine x. There's actually two formulas. It does not matter which one you use. Either one is fine. And so I need the sine and the cosine. I was given the cosine, so I'm going to need to build a triangle to find the sine value. So they told me it was in quadrant 4. I'm going to draw myself a fourth quadrant triangle. So for cosine, it is adjacent over hypotenuse, and then I could use Pythagorean theorem to find the other side, or I could recognize that's a 3, 4, 5 triangle. Since I'm in the fourth quadrant, when I find this y value right here, y is negative in the fourth quadrant, so that's how I knew to choose the -3 instead of the +3. So once I've got my triangle built to find my sine, I can look at this and say sine is opposite over hypotenuse, so sine would be -3/5. So now I have everything I need to plug into my formula. Sine is -3/5, and then 1 plus cosine, cosine was +4/5. So if we simplify that, 1 plus 4/5, we're going to need a common denominator there. So I'm going to rewrite that 1 as 5/5, so 5/5 and 4/5 is 9/5. So now I have -3/5 divided by that 9/5. To divide our fractions, we're going to keep, change, flip. So that would leave us with -1/3. All right, then for number 40, we're moving into law of sines and law of cosines. So for 40, they told us that angle A is 58, side A is 4.5, side B is 5, and they asked us to find the measure of angle B. So to begin with, when you draw these triangles, remember you have to draw the angle and the side that have the same letter opposite of each other. So we usually use capital letters for the angles and lowercase letters for the sides, but you'll notice that angle A is 58 and side A is 4.5. Those are straight across from each other. And the same thing with the B's here. All right, so since I know both of my A's and one of my B's, I can use the law of sines, and I'm going to set sine A is to A as sine B is to B. I'm going to set those equal to each other. So let's fill in what we know. So we know the measure of angle A is 58 and side A is 4.5. Measure of angle B is what we're trying to find, and side B is 5. So if I'm trying to find the sine of angle B, let's multiply both sides by 5 to get that out of the denominator. That would be the same thing as if you cross multiplied and then divided by the 4.5. That would work as well if you like that better. So now I have sine B is equal to 5 times sine 58 over 4.5. So I threw that in my calculator in degree mode because we're working with degrees, right? And I got 0.9422756624. That doesn't mean that we're saying angle B is equal to 0.94. We're saying the sine of angle B is 0.94. That's the answer. We're looking for the question. So we're playing Jeopardy, right? So remember our Jeopardy button. We're going to do second sine to get inverse sine. So we're going to do inverse sine of that value. And that gives us the 70.4 that you see here. Now, this was a side-side angle triangle. A side-side angle triangle is when you know two sides and an angle, but it's not the angle that's in between them. If I had known A and B and angle C, that's a side angle side. But since I knew these two sides and an angle that was not the one in between them, that's a side-side angle triangle, and that is our ambiguous case triangle that can get 0, 1, or 2 solutions. So when I find angle B is 70.4, that's our first quadrant answer. I also have to find the possibility for the second quadrant, and the way that we do that is by doing 180 minus the answer we just got. So 180 minus the 70.4 gave us 109.6. So both of those are potential answers. The way that I know whether they are both actual answers is I have to go back and look at my triangle and see if angle B is 109.6, the given was that angle A was 58. Can those exist in the same triangle? And yes, they can. So that means that it is also a possibility. Now, if I'd gotten something like 140 here, you can't have 140 and 58 in the same triangle. That's too big. So that would be the case where I would only have one solution, where I would have to rule out that second solution. But our 109.6 would fit in the triangle with the 58 degrees, so that means that both of these are possible values for the measure of angle B. All right, then for 41, they told us that the measure of angle A is 24.3 and the measure of angle C is 54.6 and side C is 2.68, and they want us to find side A. So again, I'm going to use law of sines. So sine A is to A as sine C is to C. And I filled in the three pieces that we knew, and now I'm going to cross multiply. So that gives me A times the sine of 54.6 is equal to 2.68 times the sine of 24.3. To get A by itself, I need to multiply by the sine of 54.6. So I'm going to do that to both sides, and I get A is equal to 2.68 times the sine of 24.3 divided by the sine of 54.6. So I threw that in my calculator over here again in degree mode, and I got 1.35 as my value for side A. All right, then for 42, it says find the area of triangle ABC if angle A is 50, side B is 10, and side C is 8. So again, if we draw that out where angle A is opposite side A and angle B is opposite side B and angle C is opposite side C, you can see the three pieces that we know right here. That is a side angle side triangle. And so we have an area formula that only works for a side angle side triangle. It is 1/2 one side times the other side times the sine of the angle that's in between them. So for us, that would be 1/2 BC sine A. So B was 10, C was 8, and angle A was 50. And again, I'm just going to throw this all into my calculator in degree mode, and it'll give me that area of 30.6. All right, for 43, they ask me, it says we have a triangle that's not a right triangle, and they told me that side B is 12, side C is 7, and the measure of angle A is 104, and they want to know little a. Now, I can't use law of sines here because to use law of sines, you have to know 3 of the 4 pieces. You have to know, like, I have to be able to set the A's equal to the B's. So I have the A's here, but I would have to know both of the B's or both of the C's. So I can't use law of sines, so instead I'm going to need to use law of cosines. So look on your formula sheet. Here's your law of cosines formula right here. So let's plug in what we know. We know B is 12, C is 7, B is 12, C is 7, and angle A is 104. Now, just throw this whole thing in your calculator at one time, and it'll shoot out the correct answer using order of operations appropriately. But if you're working on this, trying to simplify it down a little bit by hand before you put it in your calculator, just be sure that you use order of operations correctly. So we're going to do 12 squared is 144, 7 squared is 49, and then 2 times 12 times 7 is 168 times the cosine of 104. What you cannot do is 144 plus 49 minus 168. Get that answer and multiply it by the cosine of 104. Order of operations says you have to do this multiplication right here before you do this addition and subtraction. So when I do 168 times cosine 104, it gives me this value, and then I can do my addition and subtraction. But again, you can just get your calculator to do the whole thing for you. So once we know what a squared is equal to, then let's take the square root of both sides, and we'll know that side A is 15.3. When we take the square root, we get plus or minus, but this is a side of a triangle, so it can only be positive. All right, then 44 says for the triangle ABC, not a right triangle, let side A be 1.2, side B be 2.4, and side C be 2.0. So that's a side triangle. Again, I don't have a pair of anything, so I can't use law of sines. I'm going to have to use law of cosines. And I asked you to find the measure of the largest angle. So the way you know which one is the largest is it's going to be opposite the longest side. So since B is the longest side, then we're looking for the measure of angle B. So on your formula sheet, grab your law of cosines formula for finding angle B. So here it is right here. And let's plug in what we know. So A was 1.2, C was 2, and B was 2.4. And then down here 2 times A times C. So I'm going to throw that whole thing into my calculator, and you can see I got a negative 0.0666, so the 6 is repeating. And that's not what angle B is equal to. That's what the cosine of angle B is equal to. So to find angle B, I have to use my Jeopardy button, right? This is the answer I'm looking for the question. So we do second cosine or inverse cosine of that value. So you can see over here on the calculator, I did inverse cosine of that value, and it gave me the measure of angle B, which is 93.8. All right, then for 45, they ask us to find the area of that same triangle. So we have Heron's area formula, which is the area formula for a side. So first off, I'm going to add my 3 sides and divide them by 2. So here are those 3 sides we had a second ago. Add them and divide by 2. That's my S value. And then my area formula is just S times S minus one side times S minus the second side times S minus the third side. So you can see we're putting the 2.8 in for each of the S's. Here's side A, 1.2. 2.8 in for S, 2.4 in for side B, 2.8 in for S, and then 2 in for side C. And again, you can get your calculator to do this whole computation for you, or you can work it out step by step by hand, either way, but that will give you your area of 1.2. All right, for 46, we move into polar coordinates. And so for 46, it says, which of the following points is an additional polar representation of the point 2 pi over 6? So on your formula sheet, it tells you that other names for this would be, this is r theta, so r is 2 and theta is pi over 6. Other names would be r theta plus 2 pi and r theta minus 2 pi. Those are just coterminals, right? Or you could change the radius to a negative, and when you do, you add 1 pi. So let's start with this first one right here. R is going to be 2, and then we're going to take pi over 6 and add 2 pi. So if we want to add 2 pi, right now that's 2 pi over 1. If I want to add it to pi over 6, I need a denominator of 6. So I'm going to multiply top and bottom by 6 and get 12 pi over 6. So now 12 pi over 6 and 1 pi over 6 is 13 pi over 6. So again, all we did was find a coterminal of 1 pi over 6. So same thing here, I'm going to find a coterminal of 1 pi over 6 by subtracting 2 pi. So just a second ago, we added 12 pi over 6. This time we're going to subtract 12 pi over 6. So 1 pi minus 12 pi is going to give us negative 11 pi over 6. All right, then the last one is we change our radius to the opposite of what we had. So we had a positive 2. Let's change it to a negative 2. And then we're going to add 1 pi to our angle. So I'm going to add 1 pi to pi over 6. So again, my denominator needs to be 6. So I'm going to rewrite the pi as 6 pi over 6. And so when I combine these, that would be 7 pi over 6. So all 3 of these are other names for that original point that we were given. All right, then 47 and 48, we are taking the polar point 3, 4 pi over 3, and we're switching it to a rectangular. So to find our x value, you can see on your formula sheet, to switch from polar to rectangular, x is equal to r cosine theta. So this is r and this is theta. So let's put 3 in for r, and let's put 4 pi over 3 in for theta. So 3 in for r, 4 pi over 3 in for theta. Look on your unit circle and you'll see cosine 4 pi over 3 is equal to a negative 1/2. And so we can just say 3 times negative 1/2 is negative 3/2. All right, then same thing, y is r sine theta. So again, 3 in for r and 4 pi over 3 in for theta. Look on your unit circle and you can see the sign at 4 pi over 3 is negative square root of 3 over 2. And so 3 times that is where we're getting that negative 3 squared to 3 over 2. Remember, when you're looking on your unit circle, the cosine is the x value, the sine is the y value.